Hi, everybody. It is lovely to see you all again. I've been so impressed with all of the amazing coding that you've been doing over the past, 6 weeks now. Can you believe it's been that long? Um, and or certainly Laura's Jellyfish is far, far more impressive than mine. So I would love to see all of the stuff that you create. We are going to be coding and making a circuit with a servo motor. We use them a lot here at the lab because they can be very precise and move the exact distance that we want them to move. So we use them a lot here at the lab. We also use them a lot with our really cool robots that we send out into space to go and explore other planets. For us, yes, which is very, very, very cool. I think, anyway. My favorite is ExoMars, which is going up next year, fingers crossed, to go and explore Mars to see whether or not Mars, to try and see whether Mars once had life on it.
Great. So, Sophie, are we ready to make a start?
I think we are, yes. Right, so if everybody could head to Tinkercad, we will get started, because just like before, we're going to start off by building a circuit on our browsers, on our computers, so that we can test it out and write the code, and then we will turn it into a real physical circuit as well. Now, if you still have your real circuits from last week, you can use that and we can just build on it, or you can just do the servo motor bit, the new bit, the motor bit that we're going to be doing today. So I have popped the link to the Tinkercad classroom in the chat if you don't have that, and I'm just going to share my screen. Okay, so you should now be able to see. I think, yep, looks like I've got some nods. Should be able to see my screen. And what we're going to do is we are going to copy a circuit that we've used before, and then we're going to start use that as our basis. If you don't have a circuit to copy, that's absolutely fine. You just we'll just do the servo motor bit, and then you can add the LED later. So I'm going to copy the circuit that we used a couple of weeks ago and that we used again last week from session 4, which has a photo resistor and 2 LEDs. So if you get to this point, to the circuits, you can really easily copy a circuit by going to this little cog thing. It comes up with options. You click on that, and then you click duplicate. And then it thinks about it for a minute. And then a minute more. And we've got the same circuit, but it's a copy, not the old one. So I'm going to change my title. So I'm going to call it Glow Your Own Servo. And I'm going to put an exclamation mark because I'm really excited about this one. So we start with our circuit. Like I said, if you don't have the circuit to copy or you don't have the physical circuit, that's fine. I will highlight the extra wires that you'll need to do if you're creating your circuit from scratch. If you are creating your circuit from scratch, grab an Arduino, pull it over onto our work, and grab a breadboard as well. Okay, so is everybody ready to add the next bit, to add our servo motor? Give me a reaction, a thumbs up or something once you are ready. And then when a few people are ready, we will carry on. Oh, we've got some smiley faces, fantastic. Isabel looks like she's hungry. We've got some reactions and some thumbs up. Brilliant. Fab. Right. So, like we've said, the new component that we're going to be adding is a servo motor. Now you can find the servo motor in the components. So if you look over here at the components, you come down, go down a bit more, and there are a couple of different types of motors, and we use them for different purposes. What we're going to be using today is called a servo motor or a micro servo, which it means small servo motor because we like to call things micro. And we're just going to pull it over to here and just pop it down by the side of our Arduino and our breadboard. Okay, and this servo motor can move around. So these little sort of wings can move around like this, backwards and forwards. Most servo motors tend to move just within half a circle, or 0 to 180 degrees. So from here all the way down to here. CJ, do you have the physical servo motor to show everybody? Oh, you're muted, CJ.
Here we go.
Fantastic. So yeah, that's what it looks like in real life. It's got this, it might not have the little windmill thing on the top. That might have come in a separate little plastic bag that you can just pop back on. So yeah, that's what we're going to be doing. All right, thank you very much, CJ.
Okay.
Okay, so what we're going to do is we're going to wire up our servo motor, and you can see that there are 3 different connections that we need. And Tinkercad really helpfully, if you hover over each of the connections, it tells you what connection that means. So you see the one here on the left is the ground, and so we've got lots of things that connect to the ground already. We've got the one in the middle, which is power, because the servo motor needs some extra power to make it move. And then the one on the right is the signal. So that's how we're going to send the instructions to the servo motor to say, servo motor move, or servo motor don't move, or servo motor move this amount. Okay. So what we're going to do is we're going to first connect up the ground, and that is really easy. So we're going to connect it to the breadboard, clicking up here, and then to our ground line. So you remember this line with the minus sign, that's what we connect to the ground. And because it's ground, I'm going to color my wire orange like this. Okay. Now, if you're creating your circuit from scratch, the other wire that you'll need to add is to connect your minus line, your ground line on your breadboard, back to your Arduino ground pin. So you see this line here, this wire here that I'm highlighting, that connects my minus line all the way down to my ground pin. So now our Arduino is connected to our servo motor to the ground. Okay? Is everyone okay with that? Laura's okay with that. That's great. Give me a reaction. Oh, and Sarah's having a party. I like that one. Fantastic. Once you're done, brilliant. We've got some people who are there. I'll just wait for a couple more of you to be ready. As always, remember, don't worry if you don't quite catch everything. We'll be recording this and we will share it as soon as we can get everything together. And you've also got the instruction sheet so you can follow along yourself. So our next step is we are going to connect the power. And with this circuit that I've already got, you remember that this line on the breadboard next to the plus, next to the red line and the plus, that is our power line. So I'm going to collect from the middle pin of the servo motor, the one that says power, all the way up to the plus line on my breadboard. And again, because it is going to the power, I'm going to change my wire to a red wire here. Okay. So now, if you're using an old circuit, your power line is already connected to an Arduino, to your Arduino. But if you're creating your circuit from scratch, then you'll need to add this other wire here. So this red wire that goes here. So we've got this plus sign, the plus wire that goes down all the way along down here, and then to this pin that says 5 volts on the Arduino. I'm just going to zoom in so you can really see that it's connected to this 5 volts one here. Okay. Oh, we've got some people that are already there. Fantastic. And have already done this. So yeah, that needs to be connected like that. Then we've just got one more line to do. And that is connecting our servo motor to one of the pins on our Arduino so that we can send instructions to the servo motor to tell it how far we want it to rotate. Okay, so what we're going to do is we're going to go from this third pin, one that says signal on the far right hand side, and we're going to go up. I'm going to go all the way down and around because I like to be neat and have nice straight lines. Going all the way around here. And then I'm going to connect it to pin number 2. Like that. And because this is sending an instruction out, just like we're sending instructions out to our LEDs here, I'm going to change my wire to a green wire. Like that. And then, because I'm me, I'm going to make sure that these lines are nice and straight. Because it just makes me happy.
Why?
Because I like things to be straight and to have lovely right angles. It's a bit weird, I know, but that's okay. People can be a bit weird if they want to, and we should just celebrate the fact that we're all different. If you don't want to have straight lines, that's okay too. I just like them. These nice straight lines and these nice sharp curves. It's nice and neat. Okay. See, yes, Lincoln, it is very neat, isn't it? Thank you very much. I work hard to be neat. So as long as it is connecting, going from your signal pin on the servo motor, the one on the right-hand side, all the way down to your digital pin, pin 2, doesn't matter if it's neat or not, as long as you've got that connection. The other reason to keep things neat is because it does help you to spot if you've made a mistake. It's a bit harder to see if it's a bit messy, then it can be harder to see if you haven't got the connections quite right. All right, so I think those are the only things that we need to create our servo motor. So we've got a complete circuit here in our simulated Arduino. CJ, do you want to take everyone through the real physical circuit now?
Yeah, I'll take through the physical circuit of adding the servo in. And then should we have a few minutes and then go into demo? Is that good?
Sounds good.
Okay, cool. Right, so first thing is first, need to get my connection. So I'm going to move my camera down. Okie dokie. So we have our Arduino and breadboard. I've got all of the setup for the lights already in there. So we're just going to do, it's very quick setup of the servo. It's a very simple one setup. So we take it, it's got 3 wires. So we have a power wire, which is the red, and we've got ground, which is the ground. Well, sorry, we've got brown, which is the ground wire, and then we've got an orange, which will be going into our pin. And what we need to do is, as you can see, this is the flat end. So this is for pointy ends of this wire to go in, so they connect up. So if you take your servo, the connection on your servo, if you get 3 lots of jumper wires. So I'm sticking closely to the colors, so I'm doing an orange for the pin wire, then I'm going to use a red for the power, and then but I'm going to use a black for the ground. So if you could get 3 of those, so color of your choice, but if you want to stay consistent, it's easier to follow the wires. So if you get 3 of those ready, okay, we're going to first connect up our ground. So taking one end of the black wire, which is going to my ground wire, which is the brown one here on the servo. Put one end in there, and then we're going to put the other end into the minus strip on the breadboard. So in there, a lot of wires in there, but it's going onto the minus strip on the breadboard. Then I'm going to take my power wire, which is going to be red. The power wire on this servo is the red one running in the middle. So we put one end, pointy end, into our flat end connector, and then we're going to put the other end into and make sure that everything is unplugged. So don't have anything plugged into your laptop or anything at this point. So it's no power running through it. So that's going into your plus side of the breadboard. Then I'm going to get my orange wire and drop it on the floor. Oh, 1 second. Don't do that though, unless you want to, but just not necessary. Okay, so then we're going to put the one end into the orange wire of the servo, and then the other one is going to go into. Sophie, what pin did you use? Sorry, just remind me.
I used pin 2.
Pin 2, okay, we'll keep it consistent. We'll go to pin 2 on the Arduino. There we go. So that is the setup for our servo. It's very simple. And then obviously, if you're doing scaffold building, hopefully you've got your LEDs and LDR photoresist already in there. This is the idea that we build in the sensor. So we're building in the sensor here of the servo motor. And then if we connect it up, should see it. Yeah, make sure you don't have anything connected whilst you're wiring your thing. I just need to find. Okay, number. There, okay. So it's working. It should sweep like this, back and forth. Not extremely powerful, but it makes subtle movements. And if you've got several running on maybe on one object, it could probably create a lot of movement. But it's something it's a starting point for to get any movement into a piece of art or an LED. So that's that. Okay. So do you want to? Can we pass back to Sophie?
Like always, don't worry if you didn't quite keep up. You can always catch up on using the video that we'll be posting in another day or so. So I'm going to share my screen again so that we can code our beautiful servo motors so that we can get them to move. I really like the idea of the servo motors moving the legs of the jellyfish. I think that could be really beautiful. All right, so sharing my screen again, so you should all see my Tinkercad version with our lovely circuits. I'm just going to move it over to the far end of the screen so that we've got more space to do our coding. And then if you click on code, you will see the code that we did a couple of weeks ago. Now this code, as you'll all remember, turns the LEDs on when it gets dark, which is fantastic, useful code, but not what we're going to do, not what we want to do right now. So if you have this code, we don't want to delete it because it might come in useful when you're making your lanterns light up and move and do all of the things at the same time. But just so that we do one thing at a time, we want to make it so that this bit of code doesn't run. So if we change this repeat loop, so instead of saying while 1 = 1, we say while 1 is less than 1, or something, that means that this won't run because 1 is not less than 1, 1 is equal to 1. So it will just ignore this bit. So we can just move it over here and forget about it until we need it. But what we're going to do now is we're going to get our servo motor to move around just like CJ's was doing a few moments ago. And the easiest way to do that is to use variables, which we gave you a sneak peek of last time. I love variables. They help us remember things. They help the computer remember things. It's just a way of saying computer, or Arduino in this case, remember this number. Laura's got a thumbs up because she likes variables too. So we are going to create 2 variables. So if you go to this variable thing, variable set, then you can create a variable just by clicking on create variable. Then we have to give our variable a name. And the first variable that we're going to create is called angle, or I'm going to call mine angle. And that's because it's the angle that I want to tell the servo motor to move to. Now, servo motors are great because you just say servo motor, move to an angle of 90 degrees. That's the right angle. And it will go okay, and it will move to 90 degrees. So this is what we're going to call that. So which angle, how far around the circle we want our servo motor to move. So create this angle, right? But we don't want it to stay at the same angle all the time, because that wouldn't be a very exciting motor. We want it to change. We want that angle to move and to change so that our motor moves around. So we're going to create another angle. Sorry, no, we're not. We're going to create another variable. Words are really hard. It's been a long day, everyone. We're going to create another variable, and I'm going to call it change, like that. You just type the name in, and that is the amount that we want that angle to change by. Okay, so we could give it any number, but we want to change it by like 2 degrees or 3 degrees or 10 degrees. So now we have these 2 variables. Okay. And the first thing that we want to do is to tell the computer what to start them with, to tell the Arduino rather, what we want to start off with. So we're going to set angle to 0. That just means when we start the code, when we start our simulation, the motor doesn't move. It's at angle 0, and that's fine. And we're going to set the change using this set variable next, and you can change which variable you're talking about just by changing this, using this little arrow and then picking change here. We're going to set the change to, let's say 15 degrees. Okay, so that moves a reasonable amount. Some of you who have done circles and have done some maths will know that in a circle, in one whole circle, it's divided up into 360 degrees. So it's divided up into 360 pieces, and each piece is called a degree. So 15 degrees isn't very big. Once we've done that, we want to say, okay, move, and then we want it to keep moving. Right, so we're going to use our repeat loop. Just like before, we're going to have a repeat while 1 equals 1, because we want it to happen forever. So we have repeat while, then we have some maths, and 1 equals 1. All right, and then we've just got to tell it inside what instructions to send to the motor. So do a reaction, give me a wave if you are ready to send, if you're at this point. And we will, Dana's there, that's good. So that we can move. Oh, Sarah's found, you've got some great reactions today, everybody. I particularly like the octopus, Laura, that one's nice. Oh, there's a unicorn one too. That's fantastic. Brilliant, everybody. Okay, So now that we've got this all set up, we want to tell the servo motor to move. Okay, and Tinkercad has helpfully has a really easy command for this. So if you go to output, just like remember we sent instructions to different pins when we wanted to turn our LEDs on. There is a special output that is rotate servo on pin, whatever pin number, to a certain number of degrees, and that's the one that we're going to use. So if you pull this out, you've got rotate servo on pin. You remember our servo motor is connected to pin 2, so we connect that to pin 2. And then the angle that we want to move to is just this variable, angle. And so to do that, you go to variables, and you'll see that you get, you can use this variable in this nice, lovely round one, pop it in like that. Okay. Now, if we did that forever and ever, nothing would happen because the angle isn't the same. The angle is staying the same. So what we need to do is every time we go through this loop, we want to change our angle. And changing a variable is really easy in Tinkercad. There's this nice little command that says change angle by. So pull this out here. We've got change angle by. We don't want to change it by 0 degrees, do we? We want to change it by this number that we set at the beginning, by this variable called change. So you grab change and pop it in there. All right. Now, just to check that we're doing it right, we're going to use the serial monitor to make sure that the angle is changing. So if you head back to output, you can print something to the serial monitor down here. And the thing that we want to print is this angle. We just want to make sure that this command is working properly. Okay, so now that would work, but Arduinos are pretty quick, and it might get a bit, and the servo motor, it might send so many instructions to the servo motor that the servo motor is like, oh, I can't cope with with you changing the angle every millisecond or whenever. So we're just going to leave a little, we're going to make it a bit easier on the motor, and we're going to have a pause every time we change the angle. So you can go to control, and then we've got this wait. So I'm going to put wait in here, and I think I'm going to wait for half a second, say, like that. Okay, so that means every half a second, we're going to change the angle by 15 degrees, and then we're going to rotate the servo motor. We're going to move those little windmills. They might have a proper name. Sarah, do they have a proper name, those little windmill things? No. If they have a proper name, we don't know what it is. So we'll carry on calling them little
I call them
windmill things.
arms. I don't think that's very proper either.
No, I like windmill things better, I think. We'll carry on calling them windmill things. All right. So yes, every time we go through this loop, it will change the angle of the windmill. So it should move around, we hope, if we've done it right. Oh no, I just moved my Arduino and now none of my lines are straight. There we go. Right, so I was just moving it so you could see the servo motor properly. So is everybody ready to test their code? Give me a reaction if you are ready. Sarah's ready? Excellent. Oh, there's a little angel reaction and an alien and still the octopus. Do you like the octopus? Fantastic. We've got some people ready. Oh, and a tiger. I like the tiger too. I like the tiger in the Jungle Book called Shere Khan. He's very cool. He's my favorite tiger. Right. So I think we are now about ready to start our simulation. So cross your fingers to see if it works. I don't know why this has suddenly got smaller. I'm going to make it big so that you can see it again. And start the simulation. We'll see if we've done it right or not. So it's thinking about it. Now you can see that every half a second, it's moving around. And then it gets half the way around and then it stops, because that's what servo motors do. They go around half a circle and then they can go backwards and forwards, but they stay within that half circle normally. But they can go on. Some of them do go on further. Fantastic. You see it's moving around like this. All right, did everybody's move? Did anybody's move? Yeah, Sarah's did. Dane's did. And Laura's did. Brilliant. Well done, everybody. Give us a reaction if yours worked. Brilliant. Palms worked. Fantastic. Oh, if it didn't work, if you're having problems, do pop your Tinkercad nickname into the chat, and Sarah and Laura can help you and see if we can spot what the problem is.
My servo on Tinkercad didn't turn as far as yours did, Sophie. So if your servo motor moves, but it doesn't move exactly the same way as Sophie's did, don't panic.
Yeah.
Think it's just slightly different things.
Yes, it can do that. And every servo motor is actually a little bit different in real life as well as on Tinkercad. And one of the things that we do here at the lab is we try and make sure that we know exactly how a particular servo motor works. Because if a robot is on Mars and we're sending it commands to the servo motor, we want to know it's going to move exactly how far it's going to move when we tell it to move a certain amount. And so that's really important. It's a really important part of what we do here at the lab, is checking that. Fab. All right. We've got 20. Okay, so we can also make it move backwards, move forwards, and then move backwards, and then move forwards, and then move backwards, and then move forwards, and then move backwards forever and ever and ever, if we want. So if you want to do that, just before we upload it to the real Arduinos, it's a really quick little bit of extra code. What we do is, instead of changing the angle by plus 15 degrees, we change the angle by minus 15 degrees. The tricky thing is to tell it when you change it by plus and when you change it by minus. And we're going to use an if loop to do that. Very useful, a very, very useful command. So if you go to control, you can see this if loop, which is up here. And we want to change the angle. If the angle goes beyond 180 degrees, that's half of the circle. So if it's trying to send it over here, or if it's less than 0 degrees, so if it goes over here. All right. And we can do that using our maths. So in the maths, you can see we've got this triangle here that has an and in it. If you bring that out and pop it in the if loop, you can change this and to an or. And so this is a really useful bit of coding, this or thing, because it asks the computer 2 questions. It says, is this true? And the computer says yes or no. And then it says, is this true? And the computer says yes or no. And if either one of them is true, it goes, okay, well, we'll do whatever you've put in my loop then. If both of them are true, it says, yep, we'll do whatever's in the loop. And if none of them are true, it won't do what's in the loop. So it's a really useful thing. So we want to find out if the angle is more than 180 degrees. So we know how to do that. We've got this less than and more than triangle here. So let's pop that in the first one. You remember that what we want to look for is this angle. So we go to our variables and pop in angle here. And we want to say, is it more than or equal to 180 degrees? That's half a circle. But this triangle here, this means less than. So Sarah and I both remember it the same way. The pointy bit is it's smaller than the big bit, so that's the smaller bit. So this is saying, is the angle less than 180, which isn't the question we want to ask. We want to ask, is it more than or equal to 180? So your, so your symbol should look like this, with the arrow pointing towards the right. Okay. And then here we want to ask if it's less than 0 degrees. So we do the same thing again. We go back to maths. We go to this less than, pop that in there. We go to variables and put angle in here, because that's the thing we want to calculate against. So this would be less than, you change this to 0 degrees, because that's the number that we're interested in, which would be fine. This probably would work, but let's say less than or equal to, just to make life a bit easier for us, like that. So this will ask, is the motor trying to be over here, or is the motor trying to be over here? And if it is, then instead of saying change should be plus, we want change to be minus. So we do that by using the set button, set command, set block, pop that in our if loop. We want to change, I shouldn't have used the variable called change. We want this to be the variable change, because that's what we want to make different. And we want it to be minus whatever it was before. So again, we can use our maths, and we can use this operation here at the top. So this is 1 plus 1. We can change that to a 1 multiplied, so it's multiplied by. We want to make the variable change different. So we want to go back to variables and put change in here. And then we want to multiply that. So this, change this plus to a times sign up here by -1. Okay. And so it will start off as positive. So it'll be add 15, add 15, add 15, going all the way around here, add 15, add 15, add 15. We'll get to here, and then this if loop will come into play, and it will say, oh, wait, I've got to multiply my plus 15 by -1. So that becomes -15. And it will go -15, -15, -15, -15, all the way up to here. Then it will change again. All right. Again, I know that went a bit fast because I want to have lots of time to have a look at the cool jellyfish in a minute. So don't worry if that went a bit fast for you. You can always watch on catch up, and it is in the instructions as well. So I'm just going to simulate it to show you how it should look. I hope, if I've done it right, we'll find out. Start simulation. Cross your fingers, everyone. It's thinking about it. There it goes. This way, this way, this way, this way. It's going. All right, now, yes. And now it's going backwards. And now it's going forwards again. So that should just carry on forever and ever and ever and ever, or at least for as long as 1 is equal to 1. Awesome. So now we have our working code, which is brilliant. And what we want to do is we're going to upload it to our physical Arduino. All right. And we were doing that using, there are 2 ways you can do that. You can use that doing the IDE, if you've got that installed on your computer, or you can use it, you can use the Arduino app. So I'm going to use the Arduino app because it means I don't have to stop sharing and then reshare, which is as good as a reason as any. And I'm just going to pop in the chat the link to this in case you've forgotten it. All right. So yes, things have changed. Great, that's good. To get your to get the code that you need to copy in, if you remember, we go to this blocks. We change it from blocks to blocks plus text. And then we get all of this great stuff, right? Okay. And this just explains, this is in a different language. All we need to do is copy this. You have to remember to copy all of it, including all of the brackets, because otherwise it'll get sad at you. Be like, I don't understand. You haven't closed my bracket. I don't know what to do. So you just highlight it and just copy, Control C, or you can right click and press copy. Then we head back to Arduino app, go to code up here in the top left. We want to create a new project. I'm going to call mine Servo. Create. It always comes up with this code, so you just want to delete all of that, like that, and then paste. So you can do Control V, and it will put all of that beautiful pin, all of that beautiful code in here for you. Okay. And I realized that I have not connected my Arduino to the computer, so it's not going to know what I'm talking to. So I'm just going to do that so I can show you the next bit. I'll remind you of the next bit. I know you all know this bit already. Right, so that was, if you heard that noise, that was me connecting my Arduino. Down at the bottom, you can do this select device. So if you press select device, you'll see one of them says Arduino Uno. You click on that, so it's highlighted, and then you click connect. And it's like, yep, selected. That means it knows what it's doing, we hope. And then over here, in the top right, you can do this compile and upload. So that will send it to your real Arduino. So you click compile and upload, and you get an error because I've done something wrong. But don't worry about that. I probably haven't, I haven't done my actual circuit, so it could well be that. Sorry about that. Random coughing fit for you. Okay, so everyone try and upload their code. You can use the Arduino app, or you can use the Arduino app to upload it, depending on what you've got installed and how it works best for you. And then we'll see. And then once you've got your moving servo motor, you can create beautiful moving jellyfish, like CJ showed us last week.
And I can show you a moving one now. I'm just going to turn the light off.
Hey. I'm just going to stop my share so that we can see the jellyfish properly, because that's what everybody wants. That's what I want to look at. That's what I want to see too.
Okay. Oh, the movement is just.
Well, I'm going to remove the spotlight from me so everyone can see you really big, CJ. That's what everyone wants to see. You can see it moving.
That was fun.
That's so cool.
Quite slow because obviously it's only going at this speed, but that can be changed and you can speed things up and slow things down.
I quite like it moving slowly. I think it's kind of yeah, I think it's quite effective moving slowly.
Yeah, and the material, I can briefly show you how I've attached the servo to the board. So, and you can experiment with different materials to then put the jellyfish on top or whatever you're using. I can give you a brief, show you what I've done underneath.
That would be brilliant.
Okay, great. Let me turn the light back on. Right, okay, so let's take everything off. So first thing first would be to secure your servo, the base of it, to a piece of board or something, a base that you can work with. So it's not, the base is not moving and flopping all over the place. And then you can use different types of material, but I thought this, using a bit of this material here over the top, especially for the jellyfish idea. Don't have to use black tape. I only had black tape, but if you can use clear, obviously aesthetically it's going to look much better. But I placed that over the top. And then the servo motor moves the plastic bag, so it kind of goes with the material. It responds to the material quite well. It looks like it's sort of breathing. And then basically you could either use that for the form of your sculpture, so you can build with this sort of material, and then you've got a breathing sensation, or you place the fix the jellyfish onto the top of that. And with if it is slightly more movement, it does cause quite a lot of movement. Obviously, this is basic servos. The more you have, the more movement that it will create, obviously. And you can extend. You can use bigger windmills or bigger what are they called? Helicopters for different sizes of sculptures as well. So yeah, that's creating movement, and you can attach it. You probably attach it to the legs as well, but you'd have to make sure you tape them down properly so that they move. Yeah, so that's that.
Really cool. Like it.
Right.
Very cool.
So yeah. Okay.
Looking forward to seeing what other people end up making. If people have got some inspiration to make a jellyfish or something else using the servo motor, we really do want to see what you're making. So if you'd like to send an email over to me, so it's the email that you get emails from, so dane@if-oxford.com. I'll drop it in the chat. We always do really like to see what you're making.
So we've now got some code to control our servo motors. We've got some beautiful ideas to control our servo motors and make our jellyfish move, or our Christmas lanterns move, or whatever it is that you have decided that you would like to make. And I think that is the last bit of Glow Your Own, the last new thing of Glow Your Own until Friday, which is the super exciting bit, which I think, Dane, are you going to tell people what's happening on Friday?
Yeah, is our big massive switch on. So obviously we've been making our small scale LED sculptures and maybe even moving robots with some LEDs and other sorts of bits of electronics that we've been playing with over the past 6 weeks. And CJ's been making a much bigger installation that's going on the side of a building in Blackbird Lees, which is in southeast Oxford. And if you are nearby, you should definitely stop by and have a look, because that will give you an idea of the sorts of things that can be done if you have a bit more time and a few more LEDs and a few more Arduinos. So that's pretty cool. I did have a bit of a coding session over the weekend. Actually, I thought I'd do some extra. So I've got a little thing to show if anyone would like to see a little project.
Yes.
Yes, please.
Yes.
So this doesn't have any moving Arduino. I'm just going to turn off my crazy background so we can see. There we go. So just bits of box. So I'm going to show you what I've made. So it's just a cardboard box, nothing more exciting than that. And I've decided to power it with a battery. Hopefully that is better. So I've decided to power it with a little battery, a little rechargeable battery, as we learned last time. And here is the thing. So I'm going to plug it in and you'll get to see what it does. So this is just using variations on what we've done so far. And if it works, you can have it do that.
That's great. Wow.
Oh my gosh, Dane, you're so clever.
Yeah. That is like all singing, dancing. That's great.
So then I can show you inside the box. It looks a little bit crazy inside. So inside, a whole bunch of wires. So I've extended my wires like we've done, and inside the box is all this stuff. It looks like a total mess.
Wow.
But then on the outside is what we want it to look like. So it's a spinny thing. It's sort of a geometric Christmas tree or something like that. I don't know, but that's the kind of thing, that's the kind of thing you can make with the Arduino pack that you hopefully will got. You've got some extension wires.
Amazing.
Make things move. So yeah, we really want to see what you've made.
It's very cool.
Sorry to interrupt the sharing, but we've just found an error that I think quite a lot of people are going to have because it's something that keeps coming up in Arduino app. So I'm just going to explain if that's okay. So if people are getting an error, hopefully, if I shared my screen, can you see Arduino app with 100% error written on it? So we're getting, it says 100% error, and it says that servo.h, no such file or directory has been found. So servos are, the Arduino doesn't automatically, or the code we're using doesn't automatically know what a servo is. You need to, it's got some code hidden in what we call a library. So what you need to do if you're in Arduino is go into libraries, and it will load in a minute, and it tells you the kind of things that it already knows about. And we can search for a servo and click add the servo to the project. And then when we go back to the code, this time, when you try and send your code, it should load the libraries, and there we are, it's installed the servo and it's successful. And this time you get done instead of an error. So if anybody's getting a strange error with the servo, I think the Arduino IDE might already know about servos, but Arduino doesn't. So this is just to save itself space. It doesn't automatically know all the code that you could ever possibly write. You need to sort of tell it where to go and look for it before it'll work. So hopefully that fits, I think, with Lucas's problem, and if anyone else has got the same thing.
Great, thanks, Sarah. That's really helpful to clear that one up. Okay, well, it's probably time. It's just gone 6 o'clock. So thanks everyone for coming along and joining us on this tinkering and coding journey. So I think at the beginning we called it from technology trepidation to creative coding success. So I hope some people have had a sense of creative coding success, and technology trepidation is out the window. So I hope you've had fun anyway. And Sophie, Sarah, CJ, Laura, Kathy, it's been so good. I hope I've thanked everyone. Thanks everyone for joining in. All the chat's been great fun. The use of the emojis has been phenomenal. And hopefully we'll get to see you soon. Thanks everyone for coming along.
Thanks, everybody.
Thank you, everyone. Well done. You've been brilliant.
Well done.
Yeah, well done.